Welcome to this video. Here we're going to talk about experiment versus observational study, also the types of bias. So this is Unit 3, Part 2. We're producing data, surveys, and examples, experiments, and simulation. And we're first going to learn surveys and examples. Statisticians want to analyze data about a large group of individuals in order to answer a question or address a hypothesis they have about the population. Example 1. How many U.S. households watch the series Final of Succession? Example 2. What percent of registered U.S. voters approve of President Biden's plan for immigration reform? Example 3. Does an aphorism per day reduce the probability of heart attacks on the elderly? Example 4. How safe is a Volvo in a 55 miles per hour head-on collision? So those are some interesting questions that just kind of opens our unit or opens our video. So feel free to just think about it in your head about the different types of sampling methods have been used in here, and we're going to dive deep into them later. First, what is an experiment? It's a study where a treatment is randomly imposed. Randomly is pretty important. You have to make sure the data you collected is completely random. Sometimes completely random is not obtainable. In that case, you're just going to make sure that your data is random as like you can do. So there are some requirements it has to meet. First one is it can provide evidence for cause and effect. Second is well designed and get to tomorrow. So this is the notes that I did on class. So if you're in my in-person class, then I'll show you in next period. But since we're just like reviewing and doing the video stuff, just ignore this one. And observational study, we observe the current or natural behavior. And this is the observational study. The biggest difference is we cannot draw any cause effect from observational study. For example, we cannot say since A blah 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 it caused B blah blah blah. It does not work in here. Also, we are not assigning any treatment groups to the experimental population. Therefore, this is a good hint that we're using a observational study. Some requirements it has to meet. First is easy source of data. Second, it cannot discuss causation, just as I said before. And some AP exam tip, be able to determine if a data gathering process described to you is an experiment or an observational study and explain why. So just as I said before, an observational study cannot draw any causation. There's no treatment groups. It's also an easy collected data. And basically that's it. For AP statistics, experiment or observational study, here are several scenarios I want you to consider them. I know I already put the answers down for each. I feel like the answers are a little bit off, but it's okay. We're just going to go over right now, one by one. For each of the following scenarios, decide whether the study described is an experiment or an observational study. Justify your reasoning briefly. First, coffee and sleep. A group of researchers asks 200 adults to report how many cups of coffee they drink each day and how many hours they typically sleep. They analyze whether higher coffee consumption is associated with fewer hours of sleep. So this will be an observational study, right? We're not doing any treatment groups, and we're not, we're not humanly implement any treatments to the population. We're just observing our results. Second, new teaching method. A teacher randomly assigns half of her Algebra 2 students to use a new online homework system, while the other half continues using the traditional workbook. At the end of the semester, she compares test averages between the two groups. Answer. This would be an experiment, right? Pretty clear. Because the teacher is doing two treatment groups. She assigned with a new online homework system versus the traditional workbook. Therefore, it's an experiment. Third, cell phone use and driving. Researchers collect data from accident reports and phone company records to see if people who were using cell phones were more likely to be involved in car accidents. This would be an observational study because the researcher only collecting data. They didn't implement any treatments to the group, so it will be an observational. Exercise and cholesterol. A health researcher recruits 100 volunteers and randomly assigns them to either a no exercise group or a moderate exercise group. After 3 months, she measures cholesterol levels in both groups. This will be an experiment, right? Pretty clear, because we're doing two treatment. 5. Screen time and grades. A school counselor surveys students about how many hours per day they spend on social media and records their current GPA to look for a relationship. This will be an observational study. The school counselor didn't do any treatments to the groups. Fertilizer and plant growth. A scientist plants identical seeds in 20 pots. 10 pots receive fertilizer A, and the other 10 receives no fertilizer. After 6 weeks, she measures the average height of the plants. This will be an experiment because she implements two treatments, right? 7. Smoking and lung disease. Doctors track a group of 2,000 adults for 20 years, recording whether each person smokes and whether they develop lung disease. This will be a observational study. No treatments. Music and concentration. Students are randomly assigned to either listen to classical music or work in silence while taking a logical test. Their scores are then compared. This will be an experiment. Breakfast habits and academic performance. A nutritionist asks students to fill out a survey about how often they eat breakfast and then collects their standardized test scores to see if there's a connection. This will be an observation. No treatments implemented. Vaccine efficiency. A pharmaceutical. Sorry, I pronounced it wrong, but feel free to correct me in the comment. Company gives a new vaccine to a randomly selected groups of participants, while another group receives a placebo. The company monitors how many people in each group contract the illness over the next year. This will be an experiment. 2 treatments were assigned. Okay, so let's take a look at bias. What does bias mean? Bias is over or under representation of a characteristic. So either there's only 2 options for a bias to happen. Either we underestimate the results from the true value, or we overestimate that. So biases that may still remain in a carefully selected probability sample. So bias, even though we just want to do our best to reduce bias as large as possible, but we cannot completely get rid of bias. It will always happen, most of the cases. So first is under coverage. A group or characteristic is systematically excluded from sample. So this will be an example for bias, and is non-response bias is why are the subjects not responding. So think about this. If you give a experiment, or you call a phone to every family members for each household, some of the family members or some of the households choose not to respond. Well, you cannot just using the data collected from the people who respond to your survey and do a statistical analysis for it, because that will lead to bias. Because what are the reasons behind the people who are not respond? That may be related to the result of our statistical analysis. Okay. Under coverage is that you, even though it's not your purpose, but you somehow excluded some of the people, population groups from your study. Yeah. And the third one is response bias. Subjects do respond, but response is influenced by the circumstances. So, for example, like the wording bias is a good way to explain this. Bias in the wording of a survey question. If I ask you, if you vote for me, I will give you $10,000, then it would definitely be a bias. The wording bias will definitely be very effective when we doing our examination. Fourth one is voluntary response bias. It's motivation behind volunteering extreme views. So think about that. If you do a poll on the internet, the people who choose to respond to the poll most likely be 2 groups of people. Either they are extremely support your ideas, or they're extremely dislike your ideas. And the people who kind of be neutral, not leaning to either ways, they will probably most likely choose not to respond. So so at the end, the data you collected is pretty extreme. There will be like a bimodal graph if you show it on your graph or calculator. So that would not be good, definitely. And that's it for this video. We introduced several biases and what are the biases will be occurred. We also introduced the study, the observational study versus experiment. And I hope you learned something from this video. Thank you so much.